Good evening, valued guests from Asia. Good morning, esteemed participants from the Americas. And good afternoon, respected audience from Europe and Africa. A grand welcome to all of you across all continents who could join us for this international webinar. I'm Dr. Raina Raj, Head of Marketing, Natural Remedies Private Limited, India. I would be the moderator of this webinar, Natural is Future. We have with us today Dr. Todd J. Applegate. Dr. Applegate is the professor and head of Poultry Science Department at Georgia, United States of America. He has also been professor and extension poultry specialist at Purdue University earlier in his career. He was also the president of Poultry Science Association, which is a prestigious association with over 1,800 professionals who are committed to advancing the poultry industry. He is also the author of the book, Achieving Sustainable Production of Poultry Meat. He is also the author of 152 peer-reviewed publications with his research experience of more than 25 years. A warm welcome to you, sir.
Thank you.
This webinar is presented to you by Natural Remedies Private Limited. Our journey started way back in the 1950s. Our founder, Mr. Ramlal Agarwal, was a renowned expert in identification and collection of herbs. He was fascinated by the ancient Indian system of medicine, the Ayurveda. This legacy was continued by his son, Mr. R.K. Agarwal, our current chairman, by setting up a small-scale research and development facility in Bangalore, India in 1970. As our business started expanding, it fostered for the need of a bigger and a better research facility. In 1996, our existing research and development center got transformed into best-in-class facility with modern technology and latest laboratory instruments. Currently, under the eminent leadership of our MD and CEO, Mr. Anurag Agarwal, and our Director Commercial, Mr. K. Narendra Reddy, Natural Remedies Private Limited has become India's #1 herbal animal healthcare company. Our products are being used in more than 30 countries worldwide. Natural is Future is a series of webinars where we would discuss the routine challenges in animal production and possible solutions with a range of experts in this industry. To make this webinar interactive, there are options for chat, questions, and polls on your screen. If you are using a desktop or a laptop, you can see these options on the right side of your screen. If you are using a mobile phone, you can see these options if you scroll down. If you want to introduce yourselves or if you want to give any suggestions, please use the chat option. If you want to ask any questions, you can use the questions option. I would like to repeat, if you are using a laptop or a desktop, the chat, questions, and poll options would be visible on the right side of your screen. If you are using a mobile phone, you can see these options if you scroll down. If you want to introduce yourselves or give any suggestions, please use the chat option. If you want to ask any questions, please use the questions option. You can ask your questions anytime during the webinar, and we would be happy to answer all of your questions during this webinar or through your email at a later time. Today, Dr. Todd Applegate would be enlightening us about improving poultry productivity without antibiotics. Over to you, sir.
Thank you. And it's my pleasure to join all of you today. So, for all of you, we have people joining us from across the globe. Good morning to our friends in Asia. Good afternoon to our friends in Europe. And good morning to our friends in the Americas. I want to thank Natural Remedies for inviting me here today and addressing a topic. And we in the US have gone through a dramatic transition to raising birds without antibiotics. And that has not been an easy journey by any means. So I'll talk generally about consequences of what that means on rearing without antibiotics, and then delve into a little bit of what we know we need to bring forward in terms of functionality within the intestine itself. Could I have my first slide, please? So I thought I'd talk about the industry in general, because part of this transition to raising birds without antibiotics, even before COVID-19, was a shift based off of somewhat of consumer demand. And I think COVID-19 really has highlighted our need to make sure that we are conceptually being able to move into market areas that still lend us some profitability. If we look at just the larger food sector from the US perspective, and this is the same in several different countries, we had really two market segments, that being the food service and restaurant world versus that of the grocery sector. And if we split that just in terms of ratios, in terms of dollars in the US, that was a 50-50 proposition. However, if we looked at food volume, that was really 25%, 75%. So as we moved into COVID-19, we lost a substantial portion of the food service and restaurant sector, 40% in what we term the quick serve restaurant market, and over 80% in what we term the full service restaurant market. And as you can imagine, different companies had different diversifications as to how they were going into each of those different market segments. Those going into the food service and restaurant, we were doing a lot of value additions to our products to make them ready for the consumer. And this really has changed the economic value proposition for a number of different businesses. It has also created a number of opportunities for delivery of food and presentation of food that we'll see as we move into a post-COVID-19 era. We're forecasting changes in consumer behavior that will continue on into the future. One of those, really, if you see the bottom there, across different delivery options that have escalated as we've moved into COVID-19 throughout the world, so that food being delivered directly to the consumer, whether that be from the restaurant sector or whether it be from the grocery sector. Myself, I'm the one that usually goes to the grocery store once a week in our household. Neither of us really have been going to the grocery store now for over 2 months. So I'd say that adoption of that new behavior has escalated quite a bit. The other consumer behavior that we see that really impacts the discussion today is that of a broader adoption of what we'll term self-care by the consumer. And the prediction is that self-care will continue on into a post-COVID-19 era. That takes the form of exercise at home. But more importantly for today's discussion is really towards food having an impact on health. And while we've been talking about food impacting health for many decades now, it is apparently highlighted given COVID-19 today. Next slide, please. So we talk about changing demographics and how an industry needs to remain flexible to make sure that they can pivot to be able to supply products to that consumer. I'll just give you the example of what we've faced within the US, just on valuation within the broiler itself. And we've seen quite a shift just as our changing demographic has changed in the US. 20 years ago, we had nearly 60 to 70% of the valuation of that bird being in boneless, skinless breast meat, while only about 10 to 20% was in wings and legs. Our demographics over the past 20 years have substantially changed now that what we term millennials have surpassed our baby boomers last year in terms of numbers. And the expectation now from those millennials is very, very different on how and what types of foods they eat. Therefore, in the chicken world, that has really changed the value proposition on what companies are needing to supply and having ramifications then on how we rear our birds. Next slide, please. So let's talk about the no antibiotic ever era. And in the US, this has been a very rapid onset of this transition. I moved to the University of Georgia at the end of 2015, and really much of that transition has happened over these past 5 years. This particular slide, I've broken into different weight segments. And if you look at the leftmost bar within each weight segment, that was from the middle of 2014 to the green bar on the right. For each weight segment, that was December of 2018. And if you focus on those middle body weights from 2 to 3 kilograms, you can see that rapid onset of us rearing birds in a no antibiotic ever realm, going from nearly only 5% or less to as high as 80 to 85% of that particular market segment. Across all weight segments, we're well into the 50 to 60% percentile. But that really has impacted much of our industry on making that transition. And this transition has not been easy. We'll talk through the dietary aspects of the ramifications of that transition. But more importantly, realize that it's a marriage, if you will, between not only dietary mechanisms, but also substantial management mechanisms, not only on the grow-out segment, but also all the way through the hatchery and back to sanitation procedures and health status of the breeder before that egg is laid. Next slide, please. So when we talk about no antibiotic ever rearing and labeling, that has a different connotation depending upon where you are in the world. I'll give you some comparisons, at least, as to differences on how we term that and how we rear birds very differently in the US versus the EU. Our production practices in the US, vast majority, we're using recycled litter with a top dress of clean litter on top of that between each flock, with a downtime between flocks of roughly 18 to 21 days now, particularly in no antibiotic rearing. We tend to rear a much larger bird, with the majority of our birds, 60% of the meat anyway, coming from a 2.7 kilo or heavier bird. In the US, our labeling as well for producing and presenting a product to the consumer, ionophores are classified as an antibiotic, and therefore as a coccidial treatment, we cannot use those. So we're limited to vaccines and the synthetic coccidiostats. We have a growing market segment of taking away animal protein out of the diet, moved from about 14% in 2016 upwards of nearly 50% today. And when it comes to specific feeding regimens, in Europe, they do have maximum inclusions for copper and zinc. In the US, currently, we do not. And I'd have to say, as you think about this dramatic shift and getting management in tune with alternatives to antibiotics, we're relatively young in terms of trying different practices to get that as a fundamental practice. Some companies are much more mature in that process than others. But suffice to say, we are relatively young in comparison to our European colleagues. Next slide, please. So as we think about looking at alternatives to antibiotics, it's important to stress that when we conceptually as people, we often do these natural comparisons. And our natural comparison is oftentimes back to that sub-therapeutic antibiotic and what it brought in terms of consistency and productivity efficacy to our production systems. Gordon Rosen, who unfortunately passed away many years ago, did this meta-analysis of over 5,000 research studies, and he did this back in 2004 to just look at what inclusion of a subtherapeutic antibiotic had in controlled research studies. And in those studies, as we look at it, the average of those production effects were an increase to feed intake of 0.6%, improved body weight gains of 3.7%, reduced feed conversions of 0.073 with 24% less mortality. But I think it's important to realize that as we think about alternatives, really our mindset is that we really thought that subtherapeutic antibiotics were creating that differential 100% of the time. Really, they were not. And in those controlled research studies, realized they were probably cleaner environments than what we have commercially. But in those controlled research studies, that differential was only apparent 74% of the time. So this is the gold standard that we have in our mindset that we want any alternative to try to compare to. And I have to say, we do have some wonderful alternatives, and we'll talk through a little bit of those today. But that is what we call our gold standard that we are trying to achieve. Next slide, please. So as we think about what those subtherapeutic antibiotics brought in terms of efficacy, we knew their modes of action. We knew that they were antimicrobial. They reduce subclinical infections. They reduce growth-depressing microbial metabolites. And we'll talk much more about their main efficacy and why they improved feed conversion, which was really reducing the maintenance need to that gastrointestinal tract. As we go and look forward to different feed additive alternatives, we tend to categorize things as terms of their functions. And for organic acids, that's relatively easy because they, by the most part, are antimicrobial against gram-negatives. We also tend to look at categories of products such as phytogenics and probiotics, and our mindset as we initially begin to look at them tend to categorize those, but realize, and I'll talk more about this later, that we cannot necessarily treat all products the same because they can bring a range of function dependent on what they were selected for and what modes of action they bring to the table. So as we look at phytogenics, they are in some cases immunomodulators. They can change the level of stress experienced by the bird. They can have some astringent action, and they can enhance digestibility. Similarly with probiotics, it really depends on how they were selected for. Some of them can exclude specific pathogens, also have some modulatory function, and improve nutrient use by the animal. Next slide, please. And I'm going to turn it back to Raina for our first poll question.
Thank you so much, sir, for the introductory slides. May I ask our audience to turn your attention towards the right side of the screen where you can see the poll option. And under the poll option, there is a question already there. And the question is, which feed additives would you consider in your strategy to replace antibiotic growth promoters? So there are many choices. The first one is organic acids. then phytogenics, enzymes, prebiotics, probiotics, and others. We'll have 10 seconds to answer this poll question. And once we are completed with this poll question, we will quickly go back to Professor Todd Applegate's presentation. Thank you so much. Sir, we have a very mixed response. 40% of the audience feels that probiotics is their choice. 29% of the people feel that it is phytogenics. 18% of the people feel that it is organic acids. It's kind of a mixed response. That's our cue for upcoming slides. Over to you, sir.
Thank you. If I could have my next slide, please. Well, the Watt Global Media Group did a very similar survey of 385 individuals from across the world. And on your bottom left of this next slide, really you can see the partition of the demographic of that survey. I have to say, you all on the audience were not that much different than what this survey brought to bear. And as it related to antibiotic growth promotion additives, this is kind of the, I won't call them substitutes, but as they looked at that, the top rank was probiotics, followed by organic acids, enzymes, and phytogenics. The bottom part of that slide really was thoughts towards efficacy, and the green being very effective, blue being ineffective, and orange being I don't know. So as you look at those, from probiotics, feeling is very efficacious, organic acids and phytogenics as well, having substantial effectiveness. But I think if you look at that orange bar as well, really is some uncertainty in the marketplace. And I'd have to say, depending upon geography and experience, really lends itself to some confidence, at least in different categories of products. Here in the US, we've had probiotics on the market back into the 1970s. So we've had, over 40 years of experience with probiotics. Phytogenics, on the other hand, is relatively new to us conceptually. We had some in some geographical segments that was still used in humans for herbal medicines, but that concept of using those for our livestock and poultry is a relatively new concept. And so therefore our confidence is not the same, even though we do know from a scientific standpoint that a lot of those products can bring substantial efficacy to specific modes of action. Next slide, please. So as we think about this, and as you as a customer are thinking about different feed additives, often there is some hesitancy. So often that's either because of unfamiliarity with a product, or it's overselling of the plausible effects of that product. Sometimes when products are new to being researched, they may have documented effects in vitro, but not have documented those biological effects in the animal itself. We also need to look at product consistency or inconsistency from batch to batch to batch. And in certain products, we need to really verify that the active ingredient is indeed consistently there and active. And in some cases, it's very difficult, as opposed to certain nutrients, to really document the persistence from the feed to where its potential target action is within the gastrointestinal tract. Next slide, please. So that really poises ourselves to begin a dialogue on the gastrointestinal tract. And I wanted to include this quote from one of my favorite historical authors, Alexis Romanoff, who wrote a wonderful series of books that I've been reading as a poultry scientist now since I got into poultry. And his quote here about the digestive system is very pertinent to our discussion today. It is a system of digestion which has strong motives, vital drive to fill the want without question, to keep the organism alive. And one of the things that I really have taken from this quote is that digestive system is a very dynamic system and is subject to change to really fulfill a need to the rest of the body. And really, as we think about that need, it's two diametrically opposed mechanisms. One, to keep out pathogens and control them, to be able to keep them away from entering the rest of the body. And on the other hand, to break down nutrients and energy to assimilate those into the body. So two very diametrically opposed tasks, and it's going to give itself and change and adapt to be able to be able to fulfill both functions. Next slide, please. So in that maintenance need for the animal, let's look at this on average. So if we look at the gastrointestinal tract, on average, it's consuming 1 out of every 5 calories for a maintenance need by the animal. It turns over consistently, and it turns over at a rate of 50 to 75% per day. And if we look at proteins produced by the body, it's 1 out of every 4 proteins that are actually secreted into the gastrointestinal tract to fulfill both of those main functions. Next slide, please. So the gastrointestinal tract is chronically processing all of these antigens at a considerable cost to the animal. Next slide, please. And as such, we tend to lose some efficiency depending upon where that nutrient is digested and whether it's assimilated by the animal or if it is utilized first by the microflora and then potentially utilized by the animal. So if we look simply at a carbohydrate, that carbohydrate has a gross energy of 4 kilocalories per gram before it is then utilized by any metabolic process by the animal. However, if a microbe gets a hold of that carbohydrate, it's going to convert it into a volatile fatty acid. That conversion loses 30% of the gross energy potential for that animal right off the bat before it has a chance to be assimilated by the animal. So as you can see, that first and foremost is one inefficient process. Next slide, please. So as we think about the dynamics of this changing system, it's the gastrointestinal tract is going to respond. And I listed here a number of those different changes that can occur upon exposure of the animal to any stressor or any particular pathogen. And that response will depend, if it's a pathogen, on amount of pathogen and the virulence of that pathogen and any confounding stressors that create some synergy to change those dynamics. So I want you to realize that this is not a static tissue. This tissue is ultimately responding to those challenges. As an example, if it has a challenge within the gut, one of the first responses is to increase the transit rate through that digestive tract to get rid of it. And that's when we begin to experience diarrhea. One of the other things we'll talk about here in a little bit is the process of turnover of that tissue. So if one of those cells on the epithelial surface gets infected, the tissue's response is to speed up the time at which that tissue turns over to get rid of it more quickly. One of the other primary barriers, and we'll talk a little bit more about this also, is production of mucin. And mucin is that protective layer within the digestive tract to which binds different types of pathogens, and it is also home to different antimicrobial peptides and substances produced by the animal itself. And it can alter then the production rate and throughput rate of that particular mucin. there are a whole host of different changes that we see that it goes on with that digestive tract. But realize that all of those changes and the amount of change really changes the protein and energy needs for maintaining that tissue, as well as potential functionality then on the absorption side for that tissue. Next slide, please. So if we look at cost, and all of us are trying to predict what that is, ramifications then of taking away sub-therapeutic antibiotics. And again, there are a range of different stressors. The one I'm going to talk about now is just coccidiosis, and that's just one of the stressors. But I wanted to give you an impression for at least what that may be. Here in this particular study, we're looking at 6 days after challenge with a 12 times normal dose of a coccidial vaccine. So on the left-hand side of this graph, you'll see the energy, metabolizable energy differential experienced by that bird. That left bar being birds that were not challenged, experiencing about 3,200 kcals per kilo of metabolizable energy, versus those that were challenged with Cocci, well below 2,000 kcals per kilo of metabolizable energy. Quite a dramatic differential. The right-hand side of this graph gives you what that differential is in terms of dry matter retention, that difference being on 15 to 20% differential, and nitrogen retention, similarly, upwards of nearly 30% differential on overall nitrogen retention. And of course, this is at the peak of that replication cycle for coccidiosis. Again, this is one particular challenge just to show you what that dramatic impact is on nutrient and energy use by the animal. Next slide, please. If we think of that in terms of amino acids, if you look at the numbers above each of those amino acids, that is percentage of the diet differential for each of those amino acids. So if we pull your attention first to lysine, that differential in the diet on utilization is 0.17, very substantial. Methionine, not as much, 0.04. But in terms of other limiting amino acids such as threonine, very, very high as well, 0.0 or 0.17. Next slide, please. So let's talk about one of those primary maintenance needs, right? So we have some different things happening, right? So invasion, the bird's going to try and get rid of and pass that digestive more quickly through the tract. The other is that of epithelial turnover. Next slide, please. So as we think about turnover of the epithelial surface, really that's a very dynamic process involving three different processes. And sometimes those are in concert, but upon challenge, sometimes those are not in concert, right? So it's the production and division, mitotic division of new cells, typically in the valley between the villi. And as those new cells, they begin migrating along the length of that villus, they take on different functions, and ultimately they go through a programmed cell death. So birth, maturation, and death to create that integrity for the epithelium itself. Next slide, and I think it's time for our next poll question. Reina.
Yes, sir. Yes, sir. Thank you so much, sir, for taking us through till the mid of the presentation. Now let me invite the attention of our audience towards the polls option. Please click on the polls option and you can see a new question there. So the question is, do you think more researchers in the field of gut health can unlock the means of increasing poultry productivity? So you can answer with yes, no, or not sure options. We can take 10 seconds of our time. And once we are completed with this poll question, we can go back to Professor Todd Applegate's presentation. Thank you so much, sir. I think it's almost a one-sided response. 88% of the audience, they feel that um, they believe that more research needs to be done in gut health, but there is around 7% of the audience who feel that they are not very sure whether it is gut health, and 5% of the audience, they feel that they don't feel research is required in gut health. So that's our cue for our next slide, sir.
I tend to agree with the majority of that audience, and I've actually put a lot of resources in terms of our faculty and efforts towards understanding a lot of what is happening within the gastrointestinal tract, looking at different strategies to make sure that we can take care of different stressors and develop different strategies. So next slide, please. So one of the fundamental questions, and really as we look at the time course of us understanding what is happening in the gastrointestinal tract, we have to go back to when we began looking at sub-therapeutic antibiotics, and we realized that they first added to being able to reduce the feed conversion ratio for the animal. And one of the ways they looked at that was through turnover of that epithelial surface. Next slide, please. So with that, one of those first studies that began looking at this turnover really was a paper back in 1966. It did not use a lot of animals, but it set a precedent for our further understanding. The way they began looking at the turnover of the tissue, they would inject a radio label into the peritoneum. That radio label would incorporate into cells as they divided, and then they could track those cells over time as they matured and migrated along that villus. And if you look at the time points and realize this was an initial study, each of those time points represented a bird, but it was that bird at 48 hours that told us a whole lot and set the future for our concept of what this really is on turnover. 48 hours, they saw that that radio label had migrated nearly 88% of the surface of the jejunum. And therefore, our estimations were that it takes nearly 2 days for that turnover to occur. Well, that was our mindset, but realizing the duodenum and ileum that wasn't quite the same, that they had migrated nearly only half the distance during that period of time. That then set a series of research that went on then into from the 1970s and early 1980s of rearing birds either in a germ-free environment without any pathogen or rearing them conventionally. And that differential in turnover rate was amazing. In a germ-free environment, oftentimes it could take nearly 9 days for that tissue to turn over, whereas those in conventional systems is similar to what you saw here, nearly 2-3 days, if you will. Next slide, please. So as we think about that, and this is back to that 1966 paper, you see I've calculated two different things. The turnover rate for that tissue, that in the duodenum and ileum being nearly 5 days versus that in the jejunum of 2.5 days. Or if you think about it as a continual daily maintenance need, really that jejunum is replacing 40% of its tissue every single day, or 20% of the tissue within the duodenum and ileum as well. And that was in a conventional rearing system. Again, in those germ-free environments, that can be nearly as long as 8 to 9 days. Very dramatic differences. And that really is the crux of what sub-therapeutic antibiotics brought to the table in reducing the need for that tissue to respond and turn over, and therefore reduced maintenance need to the animal. Next slide. So let's look at a particular challenge. And this is a very old study from back in 1973 when they were using Emeria cervulina. For those of you unfamiliar, Emeria cervulina affects the duodenum, or the upper part of the small intestine of the bird. And they looked at the turnover rate 3 to 4 days after that challenge. So the dark blue bar is those birds that were challenged. The light blue bar was the controls. So you can see the turnover differential and that response within the duodenum. Substantial turnover in terms of the duodenum, nearly 30% per day. But realize the other interesting thing is that that tissue is going to respond in its entirety, right? So not only do you see effects in the duodenum, but those perpetuate into the jejunum and ileum and have dramatic ramifications. So not only is passage rate going to change to try and get rid of those pathogens more quickly, reducing overall dry matter, the turnover of that tissue is going to happen also more quickly throughout the small intestine. And what happens, back to those 3 distinct mechanisms for birth, maturation, and death within that epithelial surface, sometimes it becomes discoordinated when it is upregulated to get rid of infected cells. So the migration and death occurs much more rapidly versus that of which the tissue can keep up with in terms of birth of new cells and cell division. And because of that, you tend to see a blunting or shortening of that overall villus surface and a reduction to the overall epithelial absorptive area. Next slide, please. So I wanted to make sure that, I focus a few examples on coccidiosis, but there are a realm of different stressors affecting the animal. And I give you another example here, a study by Julia Dibner in the US back in the 90s when she began looking at different things from the diet that affect the differential turnover. Here was an example of oxidized fat, and you can see that those birds fed an oxidized fat, those labeled cells moved almost to the very tips of those villus versus those in those fed the control diet were only about halfway along. So those stressors such as Clostridium, different viral infections, to coccidiosis, to certain mycotoxins such as deoxynivalenol and fumonisin. All of those play a role in having a system such as the gastrointestinal tract go through some mechanisms to try and protect itself, and therefore have some dramatic ramifications on the animal. Next slide, please. So let's go back to that study. A reminder, I looked at this one particular study. One of the questions that we laid out was, could we change just nutrient and energy density to account for that loss in nutrient use? As a reminder, the bar graph on the left is what I showed you earlier on that differential on metabolizable energy experienced by the animal. On the right hand, I've given you numerically what that is. That was a differential of nearly 1,500 kilocalories per kilo. To be able to account for that change and need by the animal, we'd have to put in nearly 18.5% fat into the diet to get those additional calories to the animal. And in reality, that's just not economically or practically feasible to provide those additional calories. So we need to look at other mechanisms. Next slide, please. One of the ways we looked at providing additional nutrient was in terms of supplying additional supplemental amino acids. And in this case, as you look at the third diet, we added to our challenge treatment lysine, methionine, threonine, isoleucine, tryptophan, isoleucine, and I got isoleucine listed twice, sorry, and valine. So no challenged, Cocci challenged, plus additional amino acids. When we look at body weight, those additional amino acids did not get us all the way back to the unchallenged control. But as we look at feed efficiency in terms of gain to feed, we were part of the recovery way back in terms of feed efficiency. Next slide. So because we couldn't account for the calories, we could only partially recover part of that density. Of course, could we predict what the level of challenge was going to be in the field? Well, many times we can't. And that becomes the difficulty of our situation. And as we move into a no antibiotic production system, we need to look at how we can make sure the animal is able to cope with different stressors and different pathogens. And that's where we begin then looking at different types of feed ingredients that bring modes of action and functionality to the gastrointestinal tract. Can we meet exact needs for what was supplied by some of those subtherapeutic antibiotics, and in our case in the US, ionophores for prevention of Cocci? We can't, but we do know that we're able to bring a lot of functionality in terms of what those feed additives bring to the table. Next slide, please. So next, let's look at production of mucin. And my lab group has studied mucin over the years, and I think it's fascinating substance because it is that protective barrier. Next slide, please. And I realize this isn't a rat, but this is similar to what we see in most animals. And you have two different layers of mucin, very protective to the animal. Again, they bind to microbes, and they are home to some antimicrobial substances produced by the animal. And as you migrate through the length of that digestive tract, you see as the concentration of microbes increases towards the hindgut, that mucin layer then increases as a protection. Next slide, please. So it is protective. We can alter its composition through dietary means. As an example, if we're feeding more of a wheat-based diet, we know that the mucin produced has a more viscous composition and then affects how different microbes interact within that mucin layer. But it also is, being a protective layer, does come at a cost to the animal. We do know that threonine, as an example, comprises overall 5 to 7% of endogenous amino acid losses in the chick. And in the pig, as we look at that, we know that 30% of those endogenous losses of threonine are comprised within that protective mucin layer. Next slide, please. So I wanted to introduce a little bit of some of the research that is happening with different feed additives. One that I had many years ago was that on an extract of plants, the active substance being that of Carvacrol. And you can see here that addition of Carvacrol to the diet increased the numbers of goblet cells, both in density and total amount in that villus surface. So we know we can functionally, through different feed additives, have an impact on the dynamic of that particular tissue. Next slide, please. And this is our next poll question to you, Raina.
Thank you, sir. Before going into the next segment, I would like to request our audience to answer the third and the last poll question. So you can click on the polls option and you can see the question there. So do you think phytogenics have a vital role to play in the future of animal nutrition? So you can answer yes, no, or not sure. Once we complete this poll question, we can go back to Professor Todd Applegate's presentation, especially the last segment of the presentation. You can take 10 seconds to answer this question. Thank you so much. This is, again, a very unanimous decision much similar to the previous poll question. 90% of the audience feels that yes, phytogenics is probably a future of animal nutrition, and around 10%, 8% of the team of the audience feels that they are not very sure about it, and 3% of the audience feels that it is not. That would be our cue for our coming slides.
I'm optimistic that they will play a role, and I think we're still trying to figure out targeted roles. The range of phytogenics is interesting. Next slide, please. This is a good introduction to some of this discussion. When we look at the term phytogenics, really that is a definition that includes what we would term functional feed additives from plants. And the diversity of those potential options are as diverse as the different plant types that we have available. Typically, we think of those functional ones having some attributes being from herbs and spices, or extracts with essential oils with defined biologically active compounds, or non-volatile extracts. So I would say in the early 2000s, we did have some research, and since that point in time, a growing body of research in livestock and poultry. This is a summation from Wilhelm Windisch from Germany back in a review paper he had in 2008. Some of those purported in vivo mechanisms at that time particularly were focused on antioxidant and antimicrobial properties, palatability, additions to the diet, improvement in overall gut function, suppression of pathogen virulence, or aiding to tissue recovery mechanisms after that damage had occurred. At that point in time, when he reviewed the literature, that was either from no improvement or all the way up to 6% improvement in terms of feed conversion ratio. Next slide, please. And really, as we break apart functionality of those different plants and what I'll term phytogenics, we can think of them in two different senses. One, to the flavoring properties that they may bring to the table in terms of sensory effects, and realize that those sensory effects, especially for the bird, encompass not only taste, but also olfaction, or what the bird is experiencing in terms of smell. That overall then affects palatability, overall appetite and feed intake behavior, or masking of unpleasantness from other attributes within the diet. In terms of biological functions, once the bird has ingested it, there are also a wide range that different plants and phytogenics bring to the table in terms of immunomodulators to anti-inflammatory or antioxidant functions, as well as a host of others. Next slide, please. So as we begin looking at what we have in terms of biologically active compounds, each and every one of those plants has a wide array of now identified biologically active compounds. Here from this review back in 1996, a host of different particular plants that are utilized for their medicinal properties and categorized into those identified compounds in terms of their antioxidant, antiviral, or antimicrobial function. So as an example, oregano or rosemary have a higher number than some others in terms of those three different categories of identified compounds. We see within Asia, since we have a host of you all in the audience today from Asia, some promising phytogenics that have been used in different functions, both in human and animal medicine over the years. And those are all listed there on the bottom, from holy basil to gale of the wind, gum from the Arabic tree, or turmeric as well. So we're just learning what those are, and in particular synergies that those bring to the table. Next slide, please. So there are a number of things that we do know in terms of particular phytogenics. And again, these are very specific and wide ranging depending upon which plant we are talking about. but they do, in general, for some, have some influence on feed intake behavior, influence on microflora in the gut, can improve some nutrient and energy use. And as I showed you earlier, changes to that mucin and goblet cell numbers, as well as some effects on particular pathogens. Next slide, please. But there's a whole host and range that we need to continue to look at for specific plants. As an example, in the bird has much more perception of smell than it does taste. So we do not fully understand those mechanisms and how different substances can play a role then on feed intake behavior. Also, for specific plants, there are bactericidal or bacteriostatic effects in the animal itself, whether those effects are direct or because of microbial changes in the digestive tract, and then ultimately some other effects on the dynamics and physiology of the gastrointestinal tract. Next slide, please. So the take-home messages that I'd like to leave you with today, I hope I've presented some picture that you do not think that the gastrointestinal tract is a static system. Rather, it is very adaptive, and it really responds to the ingredient matrix that is presented to it, but then also the stressors that are challenging it. And all of these responses that the gut has to go through will alter the maintenance needs for that tissue. There's a range of those responses, and again, that really depends on the amount of pathogen, the virulence of that pathogen or stressor, and other predisposing factors. In terms of those sub-therapeutic antibiotics, as we move into rearing our birds without antibiotics, we do have fewer and fewer options for dealing with coccidiosis in particular, which largely is one of those predisposing factors for necrotic enteritis especially. In the US, we're really limited in those areas to synthetic coccidiostats and coccidio vaccines. So we need for some additional work with coccidio vaccine efficacy. And we are seeing quite a bit of research on some of our feed additives on roles that they may play, and we may be able to further refine those against things such as coccidiosis. So we need to match each individual challenge that you are seeing on your geography, your locality, of what is needed for what you're challenging, what those birds are facing, with particular roles and needs from what those feed additives bring in terms of modes of action. The other thing we're gaining much more confidence on really is the additivity or synergy across different feed additives. So it's been my pleasure in joining you today for some of this discussion. I'm going to turn the floor now to Raina and see if we have time for some questions.
Thank you so much, sir, for taking us through your very insightful presentation. There has been a lot of questions, and I'm having literally a tough time here. I have been jotting down many questions, and I have been trying to analyze if I can club certain questions so that we can cover the maximum. So I would like to start with one question, sir. There has been a lot of people who have been asking questions on the synergy of different feed additives. So the question is that, do we feel phytogenics have synergy when it is used along with other additives like organic acids or probiotics?
I'd say first off, I'll answer that question generally, yes. I think one of the things I would also like to stress is that it's very simple for us to categorize classes of different feed additives such as probiotics or phytogenics. And I think there's some falseness to that presumption, because different plants, as an example, have very different roles and functions. So it's understanding each specific product. By the same means, probiotics themselves have been selected for particular purposes, say for exclusion of salmonella or exclusion of Clostridium, or means for improving digestibility. Oftentimes they do not encompass all three. So partly it's matching very specific products under each category with each other. I think there is potential with that, and I've seen some good examples of their use towards that end, but it has to be very specific to accomplish that synergy.
Thank you so much, sir. There is a question from one of the most renowned poultry consultant in India. His name is Dr. Prajapati. Prajapati sir has asked this question: in no antibiotics ever production system, can we use chemical anticoccidials?
We do in the U.S., and what we end up doing is really both a shuttle and a rotation program. Of course, the synthetics, the downside to them, while they are very efficacious, they do tend to build resistance very quickly. So we have had to become much more reliant upon rotations with a coccidial vaccine. And I think in terms of its efficacy, that product changes a little bit, but the efficacy has improved as when we've been able to take care of application issues, all the way from how we receive the vaccine, whether it sits on the loading dock in the sun for too long, we know that it's not going to be efficacious then, how we apply it to the birds to make sure that there is more efficacious coverage. There's been several steps on that I will term in management that has led to some improvements in efficacy. By all means, it is not 100%, but each of those little steps does add to improvements.
Thank you, sir. So there have been a lot of questions on the practicability of reducing antibiotics in the Indian conditions, as well as in some Southeast Asian countries. This question was first asked by Ms. Leong. The question is how to fight mycoplasma or other similar infections like CRD, salmonellosis with less antibiotics. I would like to add, sir, there has been some similar questions like you can go without antibiotics or reduce antibiotics during brooding and during deep litter system also. This has been asked by some of our esteemed customers like Mr. Arindam Chakrabarti, Vishnu Hari Sharma. So this has been a popular question out of the all of it.
Yes, and I'd say it has not been an easy journey, and it is not an easy journey to go through. The one thing that, while a lot of my talk has been related to complete removal in our situation, there are times where we do see additivity to preventing subclinical infections from a number of different gut modifying feed additives that are not sub-therapeutic antibiotics. Our situation in the U.S. is probably unique versus other countries as well, as to what tools we have available to combat different infections, right? If we look at our portfolio of what we have available from therapeutic antibiotics, that is greatly diminished as well. So that will be different than what you have available as well. Our use of those, really has taken a lot more diligence to do diagnostics and preventative care. But again, this journey is not easy, and it is a marriage. I referred to it as a marriage earlier of this combination of attention to diet, more dialogue with our veterinarians, more dialogue on management practices throughout the production system. But it does have ramifications. One of those ramifications I haven't talked about either is giving that bird more space. And that is quite an economic consideration as well. More space, different litter management practices between flocks, possibly to give some composting, increased amount of time between those flocks to reduce some particular pathogen load. So it again is not an easy journey to go through.
So there has been a question from another renowned consultant in Indian poultry industry, Dr. Sudhir Rukadekar, sir. So he has a question that in the presentation we had mentioned no usage of ionophores in the no antibiotics ever broiler birds. Would coccidial vaccines has a practical application, especially in Indian or kind of tropical climates in broiler?
So ask your question again. Is it more related to the vaccine or to ionophore? More to the vaccine?
Vaccines, yes.
Yeah. For clarification, in the U.S., we have two particular agencies. One which approves our feed additives and drugs, and that's our Food and Drug Administration. We have another agency located under our Department of Agriculture, which regulates the labeling of consumer products, right? So our FDA does not consider ionophores an antibiotic, but for labeling of the chicken we're going to eat, our Department of Agriculture considers ionophores a antibiotic. The vaccines in your geography, climate, do have some efficacy, but again, you would need to make sure that the products you are utilizing are consistent with the species that you're facing. And even then, I would say some of our vaccine options here, some of those strains included within some vaccines have lost some efficacy, right? So Emeria maxima is the one that we have our most challenge with here in the US. And there are some strains that struggle to provide sufficient immunological reaction to be able to develop a protective response in our birds. So what that challenge is differs country by country to some degree, and therefore sometimes vaccines need to be developed specifically for what is faced in your situation.
Right. So there are a lot of questions asking for some more information on the effect of antibiotics in humans. This was first asked by Sherlyn Cassivan. So she had said that antibiotics usage as additives can cause resistance to different microorganisms in poultry. And it was a kind of a suggestion from their side. And can you throw some light on the possible effects of these antibiotics extensive usage in humans?
I'm not sure I want to comment on the human side of the equation, because I think on the animal side, we have needed to pay closer attention to our use or overuse or not being site specific. I'd say we have the same issue on the human side as well. And in each side, I'm happy that there has been more collective dialogue between our animal agriculture world and our human medicine world. But suffice to say, we both have issues, substantial issues on the human side. And I think part of what is often lost when we go to talking about these issues in general is that we break it down generally, just as we lump things into the phytogenics, lump things into the probiotics, we often lump them into antibiotics, and realize that we need to begin to change a little bit of that dialogue, especially from us within animal agriculture, as we talk about the human medical equivalents, whether we're talking about the human medical equivalent antibiotics versus those that we do not share with humans. And in our situation, we've lost a lot of the human equivalent antibiotics as tools in in our commercial poultry production. So.
Thank you, sir. There's another question from, again, a renowned Indian poultry consultant. His name is Dr. Manoj Shukla. So Dr. Manoj Shukla had asked a question. It's a very, very practical, pertinent question. What is the right thing to do? Is it antibiotic-free egg and chicken or antibiotic residue-free egg and chicken?
I would go with the residue. But part of, let me be clear. Part of the reason that we made this dramatic transition was it was mainly because the retail customer, the quick serve restaurants, the food service sector, they wanted to label and market to the consumer a no antibiotic ever product, right? And because of that demand and customer contract, the poultry world said, yes, we'll supply, right? So whether that's right or wrong, I tend to agree with providing no residue in that ultimate product and attention to that. That retail customer for us essentially drove that market that direction.
So there is a question from Mr. Carlos Lopez. The question is, what do you think about the legislation of phytogenics? As per him, right now, there is no specific regulations for plant extracts for essential oils. Some of them are used for treating as flavoring agents. There is one more addition. Will it become more strict in the near future about the dosages, trials, etc., to demonstrate its effectiveness?
I would say that it depends, and I think part of it gets into what our knowledge of whether things are going to be concentrated. As an example, there are some compounds that we know can have very toxigenic effect from certain plants. So creating, some particular plants, even in concentration of those, we would not run into any particular issues. So I think we need to find a middle ground. There are some plants where we need to make sure that as those are concentrated, we don't run into any toxigenic effects from them. But I think there will be some ease to make sure that we can account for those. But there are some things that I think generally have been used safely at certain doses for many decades. And so I don't want to create too many hurdles for utilization of those products. But yet I think we do need to ensure safety for the animal, for our consumer as well. So a little bit of a middle ground someplace, but I don't think it should be widespread for all.
So we have a lot of questions to be answered. I'll take last two questions. One question is from a very close associate of us, Mr. Behram. So his question is, what do you think about the anti-inflammatory effect of phytogenics? Would that be a key for intestinal integrity?
The anti-inflammatory part has a role. I think the other thing to really think of with that, while we have chronic inflammation, yes, it can improve chronic inflammation, but I want to make sure that it is not anti-inflammatory to the degree that it becomes immunosuppressive, right? So those are two very distinct items. I still want that animal to be able to respond to a challenge and deal with the pathogen, clear the pathogen. And so I think of it more in concert. So yes, anti-inflammatories can play a role, but I want that animal to be able to respond more quickly, deal with the challenge, and get back to its productive purposes more quickly.
Great. We'll come to the last question. The question is from Mr. Rakesh Nimbalkar. The question is, do we need to alter the dosage of phytogenics in different phases of broiler, considering the gut development and the balance of the microflora? This is one question that we keep on getting, when we interact with our customers.
I think it's a great question. It's hard to give a general answer to that question because I think, again, it depends on those specific modes of action of which phytogenic product we're talking about. It may have different roles at different points in the bird's life, whether that's a stimulant and digestive role, which might play early on in production or late in life, or if it's targeted more towards pathogen suppression, say against Clostridium. We know in the U.S., as an example, we're gonna hit a peak in necrotic enteritis probably between 18 and 21 days of life, right? So if we're looking for particular products, we know they have that particular role and function. We're gonna look at the second phase diet to target that product more so than others when we're targeting a particular role and function.
Thank you so much, sir. We have taken a lot of your precious time for interacting with our audience and to get the answers for the questions. I really thank you from the bottom of my heart for being so open and very, very supportive towards us for this effort of us. Thank you so much, sir.
It's been my pleasure. I appreciate the opportunity to interact with you and your audience.
Thank you so much. So thank you so much, our dear audience who could join us from all parts of the globe. We have had a perfect mix of our audience from more than 26 different countries, and considering the different time zones, it is a very big opportunity for us to thank you for being in this webinar till us. Also, you have been very interactive during the session, and the number of chat messages and questions we have received is a proof of that. There are plenty of questions which we couldn't answer during the webinar due to the paucity of time. I assure you that all of the questions would be answered through your email. If you have any more suggestions or questions, please contact our local representatives. We have our country managers and our business partners in all countries that we operate who can be approached anytime. Or you can write to us at raina.r@naturalremedy.com. This is my official email ID, and I would be very happy to receive your suggestions and questions. Our audience from Far East as Philippines, Malaysia, and other Southeast Asian nations, I bid you good night. Our audience from Latin America, United States, Europe, and Africa, I wish you a great day ahead. Our dear audience from India and Indian subcontinent, I wish you have a good time at dinner. See you next time with another topic and another eminent speaker. Thank you again.